copy and put that file on some other machine and run that virtual machine there. So it's like as if you are sending a PowerPoint file by email from one machine to another machine. You create the PowerPoint file in one machine, send it to the other side, and that person can load it on that machine, right? Likewise, you can create an image of a virtual machine, put it on another machine and run the virtual machine there. So what it makes it portable. Portable means you can just move the virtual machine from one machine to another machine. So same thing with servers. So no longer your servers are running on specific hardcore machines, host machines. You can move your servers from one machine to another machine. So this provides you the portability. Okay. So okay. So now the kind of more the details. So there is a kind of software called the virtual machine monitor, but commonly called the hypervisor, that acts as an interface between the underlying hardware of your host machine with the individual virtual machines. Okay. Now, this is the simplified point of view. Now you will have the host operating system also interacting with the hypervisor, depending on what kind of architecture you're going for. So we'll see the details as we proceed. But this hypervisor is what is actually acting as the interface between the virtual machine and the host, right? And one example is your virtual box that you will be using for your project, Oracle VirtualBox. There are several other software also, like VMware has its own workstation and all those software. Okay, so several examples for hypervisor. Some are free, some are you have to purchase them. Okay, license. VirtualBox is free, right? So now, what architecture is really used? Well, these are the two broad categories of architecture: the hosted architecture and the bare metal architecture. So in the hosted architecture, as you can see, the virtual machine monitor doesn't directly interact with the hardware, it interacts through the host operating system. So this could be your say Windows 7, and this could be now your Linux, Ubuntu, and this could be your Mac, and this could be even an XP operating system. Okay? So the advantage is, for example, there may be some software that can run only in XP. So that doesn't mean that you need an XP machine, a standalone XP machine. Similarly, there may be some software that runs only on a Mac. You don't need a real Mac machine, right? So you could create virtual machines and run all those software on the virtual machine. So you're kind of saving the money that you have to invest on the hardware. Because nowadays the hardware has developed so much, you can have multiple cores and all those things, and all the RAM, memory available, and hard disk space available. You can make use of all these resources. Okay, and that's where the industry is going to. And eventually, virtualization is actually the backbone for all the cloud computing thing that you might be hearing this term, right? So the whole industry is moving towards the cloud. You need not store anything locally, just store everything in the cloud. Of course, security is an issue there, but there are some standards to also provide security in the cloud. Okay. Now, even again, if say in traditional sense, if you run only one operating system and run all the applications on it, on the underlying hardware, if something happens to an operating system through that application, what will happen? You have to wipe out the whole operating system, the whole hard disk, and reinstall everything from scratch. Whereas if some virus or something is infecting a virtual machine, it's not going to impact the other virtual machines and even the underlying host operating system, especially in the hosted architecture, because everything still is of course a trade-off. All the control still goes to the host operating system. Okay, so the host and the other virtual machines will not be affected because of some virus or anything. Now, in the bare metal architecture, the host operating system is not at all there, which means this is more used for like embedded applications, embedded systems. For example, if you have some medical imaging applications where you have to have some real-time processing of the images, as well as there is some general purpose computation needed. Okay? So you can run each component of an application as a separate virtual machine. Okay? The thing is, when you have to go through the host operating system to access the underlying hardware, it takes some time, as we'll see in a couple of examples soon. Whereas when you can access the underlying hardware directly, it can be more faster. Okay, so that's the advantage of the bare metal architecture. But this is kind of more customized for specific applications, where this is more kind of generic, in the sense that you can plug and play whatever virtual machines you want. Whereas this is more customized for specific applications, you can run all your virtual machines directly on the underlying hardware. Okay? So now what role this virtual machine monitor does? The virtual machine monitor has to kind of act like a police basically, because you cannot let all your virtual machines to directly access the underlying hardware as they want. Okay? So it has to kind of intercept all the instructions, okay, coming from virtual machines to access the underlying hardware, and then regulate the control. So in this case, it goes to the host operating system. The host operating system acts as another extra layer of protection. So only if all those requests are valid, it lets those instructions coming from the virtual machines to be executed on the underlying hardware. Okay, so it all takes time. Whereas in this case, it still acts like a kind of protection by intercepting all these requests, but it's generally more faster than this because there's no host operating system involved. Okay, so also, like when it's talked about the ISA, remember the instruction set architecture, right? So all these virtual machines, since they access the underlying hardware directly, they have to know they have to be compatible to the underlying instruction set architecture. So there's another limitation of bare metal architecture. Because here, as I said, these could be different operating systems. As long as this host operating system can run on the underlying hardware. So for example, if this is Windows 7, it can run on all x86 hardware. So as long as the host operating system can run on the underlying hardware, it doesn't matter what virtual machine you run on the top of it, because everything goes to the host operating system. Alright? Whereas here, the virtual machines, the operating systems you are using have to be compatible with the underlying hardware because they directly interact with the underlying hardware. Okay, so that's like another trade-off between the two. Okay, so let's see specific cases of how they work. So kind of cover this. Another situation where you can use a hosted architecture is, for example, if you are in the software development stage. Right, there may be some bugs, or sometimes when you run your software when it's in development stage, it may even crash the system, right? So for such scenarios, you can use virtual machines, because if it even crashes, it's going to crash only the virtual machine. It's not going to crash the entire system, right? So for all software development, beta testing, alpha testing, and all those purposes, you could use virtual machines. Okay. And for running legacy applications, as I said, there are still some software that runs only on XP, right? So for that, you don't need to really use an XP machine as standalone machine. You could just create an image of an XP machine and just run your application there on that XP virtual machine. You don't need really a standalone XP machine. Okay? So now, since all control goes through the host operating system, but of course, for doing all these things, your host operating system has to be reasonably powerful. So don't try to run a virtual machine on a very dumb or kind of ordinary host machine. It will slow down your whole system. Okay, so you have to have at least like about 8 GB of RAM, and hard disk space also matters, and then the processor speed and all those things. Because as you'll see now, what happens? So now how are these really implemented? So we saw the hosted architecture. So in the hosted architecture, I said all control goes through the underlying host operating system. So it could be implemented using these two techniques. One is called binary translation or full virtualization. The other is called para virtualization. So, and the bare metal architecture could be implemented using the hardware assist technology. Okay? So these two are used for hosted architecture, and the last one is used for the bare metal architecture. So that's what we're going to see, how these three techniques are going to work. Okay, so said so let's say this is like a hosted architecture where you have one virtual machine running on the machine host, and then you have the host, some applications are running. Now the virtual machine monitor plays a very significant role here. Okay, so let's say there is some instruction, a privileged instruction. So for example, to access an input-output device of the host. Okay, the virtual machine is trying to access that input-output device, some privileged instruction. So you know what's a privileged instruction from an operating system point of view? Something that requires the if from an application point of view, if you launch a privileged instruction, it requires to go through the operating system to access the underlying hardware. You cannot just access the hardware directly. Okay. So in this case, let's say an application running on a virtual machine wants to access the underlying hardware, input, output, or something like that. So it goes through the guest operating system. By the way, I didn't introduce the term, but you should be familiar by now. The operating system running on the virtual machine is called the guest operating system. Okay? And the operating system running on the host machine is called the host operating system. So that should be straightforward terminology. So the virtual machine monitor or the hypervisor intercepts that instruction, and what it does is this. You see that the virtual machine, for example, you're running a Mac operating system. You know, Mac operating system will have an instruction set architecture that normally corresponds with this PowerPC hardware, right? So that is the hardware typically on which Mac operating system is run. Like Windows runs on x86 and all the Intel architecture, Mac operating system runs on this PowerPC hardware. So the instruction coming from the Mac virtual machine will be according to that ISA. Alright? So what this virtual machine monitor has to do is, it has to do what is called a binary translation. It has to basically translate the code that is according to this ISA, instruction set architecture, to an instruction set architecture that corresponds to the host operating system and the underlying hardware. So for example, if you are running Windows 7 on x86, it has to do the translation of the binary code of your application running on the Mac system to a binary code corresponding to this ISA. Right? So the virtual machine has to do this binary translation. So it's like you have a code written in one instruction set architecture, a binary code executable. You have to translate that to another ISA, because why? That code, after you translate, it goes to the host operating system. The control is transferred to the host operating system, and the host operating system executes that code on behalf of the virtual machine. Alright? So whatever the results that come out are again forwarded back to the virtual machine monitor, back to the application. So that's why it provides you the flexibility. Whatever be the virtual machine or operating system that you run on top of the host doesn't matter. But internally what happens? The binary translation happens. So the instructions that you issue from a Mac operating system, for example, are internally translated to correspond to something that corresponds to the instruction set architecture that goes with the host operating system and the underlying hardware. So it is this binary translation that provides that emulation. Emulation means what? It appears as if you are running a Mac operating system on a x86 hardware. You know that you cannot run Mac on a, say, an x86 hardware directly on the top of it. But this virtualization provides you an emulated view that you are able to run. But how that emulated view is obtained? Through this binary translation approach. So the instruction set architecture corresponding to one combination of operating system and hardware is translated to the underlying instruction set architecture for the host operating system and the underlying hardware. So it takes time. So it's not a simple job, right? So that's why when you run these virtual machines, you could see the kind of delay involved. Okay? So in order to get a kind of feeling that it is running reasonably fast, this translation has to be done faster. Alright? So that's why you need more kind of resources, kind of RAM, the processing capacity of your underlying machine, and all these things. Right? Otherwise it will be very slow. Okay? Any question on this? So we'll stop here. By continuing